You were right! It really flew!
I knew it would. It works the same way as a rocket.
That may be true, but it still looks more like a balloon than a rocket.
I said it works the same way. I didn't say it was a rocket.
How does it work?
What I mean is, if rockets can fly like our balloon, it's for the same reasons. You understand?
Well, not really.
Imagine that... I know what! Why don't we go and ask Jeannie? Wow, that's a strange name.
I can't even pronounce it, can you?
Whee! It's easy. Tsiolkovski. You never heard of Tsiolkovski? The space age we live in today owes him an awful lot. Why, there'd be no satellites or rockets if not for him.
Huh?
Follow me and you'll see what I mean. Here he is, Konstantin Tsiolkovski. His work led to the invention of the rocket. We're now in Tsarist Russia, 1 century ago.
There he comes.
Great, let's have a little fun with him.
Hey! How are you, Daffy?
Let's get him.
Okay,
What do you say we steal his bread? That'll be fun, huh?
let's go.
My bread! Give it back to me! Why won't they leave me alone?
Ah! This bread is as hard as a rock.
When he was 9, Tsiolkovski developed scarlet fever. It made him half deaf. Life wasn't very rosy for him. But Tsiolkovski was a determined young boy and intelligent too, like a certain rose-colored friend of yours, if you know what I mean. Oh! Where's Tsiolkovski gone to? I'll bet anything he's at the bookstore trying to find a book on... Ow! Oh!
Oh, I'm sorry, Jeannie.
I've brought your bread back.
Oh, thank you. I haven't had a thing to eat.
Instead of buying all those books and equipment, you should think about eating a little. At least buy yourself a potato or something.
That's a real luxury, if you knew how little I've eaten over the years. But I don't mind. I have very little money, I know, but I have enough to live on and to continue my work. That's all I care about, to continue studying, doing research, and finding answers.
And so, in the heart of Moscow, he continued his work, alone, determined, and never discouraged.
You know, I feel almost lucky to be partially deaf. The noises of the city don't disturb me. I live in a world of peace and quiet. It's a shame that children make fun of me.
Tsiolkovski made a lot of progress in his work. But in all modesty, I've got to admit I helped him a lot. That's right, I'm Jeannie the Genius Maker. What would they do without me? Ow! You know who Jules Verne was, don't you? He wrote this fantastic book, From the Earth to the Moon, in which 3 men and 2 dogs were propelled to the moon by an enormous cannon. A kind of spaceship replaced the cannonball, in which they re-entered the atmosphere using a retro rocket to slow them down. Verne's science fiction novel fascinated Tsiolkovski, who was seriously studying the possibility of traveling in space. He earned his living as a school teacher, but he continued his scientific research on the universe. What are you thinking about?
I'm convinced that most of Jules Verne's theories are correct.
But I thought it was only a science fiction story.
It is, but his novel is based on serious scientific principles. In fact, He's a sort of pioneer in the conquest of space. He calculated the speed necessary to leave the Earth thanks to Newton's laws. He also knew that the friction created by re-entry into the Earth's atmosphere would cause overheating. If we can perfect some of Jules Verne's intuitions, I'm certain that we can find a way to send people to the moon. There are a few problems. For example, I think that the propulsion force is not sufficient to break away from the Earth's magnetic force. We would need a cannon which could propel an engine at a speed of 6 miles per second. But with such an acceleration, the people in the capsule risk being totally pulverized. I wonder what speed human beings are capable of bearing. Would you like to give it a try, Jeannie?
Thanks to acceleration experiments performed with hens and rats, he saw that the animals were capable of withstanding 5 to 6 times the gravity of the Earth. Pretty good, huh?
We must find a way to decrease the effects of acceleration.
Hey, I'm not deaf.
If you want to help me, Jeannie, take this can and drop it from the air.
Okay.
There you go.
I don't know what I'm doing, but I guess Mr. Tsiolkovski does.
Higher, Jeannie, higher!
Well, is this high enough? The can's getting heavy! Timber! I wonder what he's put inside the can. Egg and water? That's weird. Hey, it's going too fast! I can't slow down! Help! Hey, I'm gonna break something! Ah!
Just as I thought. It didn't break.
Now I'm completely lost.
I just wanted to prove that an object placed in a container full of water would remain intact despite the shock.
What a genius! In 1883, Tsiolkovski began to study the principle of satellites. You know, of course, that the harder you throw a ball, the further it will go. And it falls to the ground because of gravity. Or wait, like this apple. Gravity attracts all objects to the ground. Tsiolkovsky's principles of astronomy were based on whose work? Yes, that's right, on the works of Newton. But now let's see how a satellite is launched. In order to place the ball in orbit, it's got to be launched at a sufficient speed. Tsiolkovsky calculated the necessary speed for orbiting. The ball must go around at a speed of 5 miles a second. But in the atmosphere, the air friction quickly makes the ball slow down. That's why it has to be launched above the atmosphere, at an altitude of at least 100 miles.
Professor Tsiolkovski, Professor!
Your students are calling.
Huh.
Professor, you promised that you would launch a balloon today!
Yes, I did. Let's go.
Hooray! Hooray!
To amuse his pupils, Tsiolkovsky would make hot air balloons. He would make a fire underneath to heat the air, allowing the balloon to rise. As a teacher, his deafness bothered him a bit, but his students were so fascinated by him that they worked hard and paid attention.
The balloon's filling up, look! It's flying, hooray! We did it! Yay! Hooray! Hooray! Yay!
Ah! No!
We will not win!
Did you see that?
It's a balloon.
Look!
Come on, let's follow it!
Huh? What's going on? What is this thing, anyway? So, you think it's funny, you idiots? Would you mind keeping your toys off my roof in the future?
But it's not a toy, sir. It's a very serious scientific experiment.
What? You don't know what you're saying. Here, take it and go.
You could have been a little more careful. You could have torn it.
Yes, that's right.
Sure, fly a paper balloon in the air and call it an experiment.
It is an experiment. Our professor's a great scientist, and what he invents won't be thanks to you.
What's going on here?
He's insulting you.
Oh, it's of no importance, children. Let's go back.
I hope you're not thinking of using a balloon to travel to the moon.
Oh, there's no air in outer space. But what do you say to using a rocket?
A rocket? In the early 19th century, the army used rockets like this one to bombard the enemy. But except for that and fireworks, they seemed to have no other use. Tsiolkovski was convinced that they would one day be used to send men into outer space. But I don't understand how a rocket can be used for space travel.
First, you must understand the principle of action and reaction.
The principle of action and reaction?
According to this principle, a ship's oars push the water, allowing the ship to go forward. In the same way, a bird's wings push the air, allowing it to fly.
There's just one problem, Mr. Tsiolkovski. There's no air or water in space.
You're right, they might not have been the best examples. Nevertheless, the principle of action and reaction are the same in space.
Yes, well, you're probably right, but I don't understand.
Let me explain. Watch closely.
A blue balloon.
You see, the balloon flies as a result of the reaction. The gas trapped inside creates a thrust as it escapes through the opening. It's the same thing for rockets. They'll fly even better in space since there isn't any air to slow them down. But where are you going?
To check out if what you say is really true.
But you can't, Jeannie.
I can't? And why not?
Because the pressure is zero in space and the air in the balloon pushes against the sides, breaking them.
Yes, but you said that it was the exact same principle as the rocket.
I know, but there are principles and principles. In a rocket, the compressed gas is locked in a hard enclosure, and so it can't escape through the opening, thus creating the thrust.
I'm going to turn into gas to check this out. Rockets are propelled by reaction. The gas compressed in the tank puts pressure on the walls. When the gas escapes by reaction, the thrust created makes the rocket move forward. Hey, you were right! In 1903, Tsiolkovski put all his findings into an article called Space Exploration Using Reactor Engines. He explained the principle of propulsion by reaction, demonstrating that it could function in a vacuum, and giving the mathematical formula for the speed achieved by a rocket based on the speed of the escaping gas. He also suggested the use of a liquid fuel rather than cannon powder. With liquid fuel, it would be much easier to control the fuel distribution by using valves. And don't forget that oxygen is necessary for fuel combustion, since there's absolutely no air in space and therefore no oxygen.
People must realize that space travel is not merely science fiction.
Tsiolkovski sent his article to a Moscow journal, the Scientific Observer. 1903 was also the year that the Wright brothers made the first real airplane flight aboard a glider equipped with a motor. And though the distance they covered was only 90 feet, Tsiolkovski was dreaming of sending people into space. Unfortunately, the journal's editors refused to print Tsiolkovski's article, and his work went completely unnoticed. He had to wait 20 years for his works to be published. And for people to finally recognize how important it was. Ah! Help! Soon after, World War I broke out, devastating Europe and leaving millions dead. In 1920, Tsiolkovski, still as determined as ever to conquer space, published a science fiction novel, Beyond the Earth, based on his scientific research. His book went from the invention of the rocket to a trip to the moon, not to mention other planets like Mars, before finally returning to Earth. This reminds me of the egg floating in the can.
Ah, you remember, Jeannie. The egg remained intact when the can fell.
Whoa! Wow, this is fantastic!
It's called weightlessness.
I can understand why. I feel as if I don't weigh anything. All of these wonderful adventures were described in Tsiolkovsky's novel. How about this? He's even wearing a spacesuit. It looks a lot like the ones astronauts wear today. I want to wear one too! Oh, great! Hey, wait for me! Ah! Hey, I'm drifting! Help me, please!
Coming, Jeannie.
It's not very easy to move around in this suit.
You mustn't forget that you're in space.
That's better.
Oh, Jeannie, you're too much. If my novel's a success, I'll have a bit more money. But more important even, people who aren't interested in space might read it.
The Russian Revolution of 1917 brought a new regime to power, which encouraged Tsiolkovsky to continue his research. At the age of 60, Tsiolkovsky quit teaching in order to devote all his time to his first love, space research. And he continued to develop his ideas for the conquest of space. He felt that a manned space station would be very useful, and he devoted lots of time to this idea. He was also the first person to present a plan for launching a space vehicle with a multi-stage rocket. They would separate one by one as soon as their fuel was exhausted, allowing the space capsule to reach its goal. Do you mind if I ask you just one more question, okay?
Yes, of course.
How can anyone invent a rocket if no one has ever gone into space to see if the theory works?
That goes back to when I was a youngster. One day I wanted to measure the distance between 2 points. To do so, I used an astronomical compass I had made myself. I calculated the distance as being 1,000 feet. Then to check my findings, I used a spool of thread. And it came to 1,000 feet. My calculations were correct. And so I concluded that if a theory is correct, then the results of the theory must also be correct.
Now I understand.
As for my theories on space travel, I cannot swear that all of them are totally correct, but I am certain that in the future, they will be verified and used by scientists.
Robert Goddard, an American, was the first to use Tsiolkovsky's work. In 1926, he made the first successful launching of a small rocket using liquid fuel. Look! In Moscow, in front of the Space Conquest Monument, there's a magnificent statue of Tsiolkovsky. A century after Tsiolkovsky's birth in 1957, the Soviet Union launched the very first satellite, Sputnik. And in 1959, Luna 3's photographs gave the entire Earth its first glimpse of the hidden face of the moon. One of the first craters to be discovered there was given the name Tsiolkovsky. What a nice way to pay tribute to him. And in future centuries, man will be able to go further and further in our solar system, much further than Tsiolkovsky ever imagined. We'll talk about that another time. So long, kids!
have your attention, please? In front of you is the planet Jupiter. The time is exactly 2 p.m. This afternoon, you have a wide choice of films from our onboard movie library. Select the program you wish on your personal keyboard.
I'd like to see the first men on the moon again.
The moon, Neil Armstrong, 38-year-old American, standing on the surface of the moon. On this July 20th, 1969.
It's one small step for man, one giant leap for mankind. Truly one. One in their pride in what you
It's
have
time for dinner back here on Earth, kids.
Already? Yay! It's fantastic!
It sure is. Next stop, Mars. Thanks, Mr. Tsiolkovski.
Thank you!